They really came after everybody in 2024 with this number six. And number six is always going to be your Maclaurin-Taylor series question, some type of series question. This was very technical. I felt like, oh man, they really came after you with understanding your properties, which is fine. Again, it depends on how you learned it. So they gave me a Maclaurin series, and here it is. And it converges to f of x for all x in the interval of convergence. It can be shown that the Maclaurin series for f has a radius convergence of 6. So f has a radius of convergence of 6. Determine whether the Maclaurin series for f converges or diverges at x equals 6. Give a reason for your answer. So you need to plug 6 into this for x and simplify it. That's your first rule for part A. Don't overdo it. Now, I found this interesting because this was a direct comparison test. So they came right out of the chute, they came after you. So at x equals 6, the series is, now remember it's x, so the sum is n equals 1 to infinity of n equals 1 to infinity. N plus 1, leave it alone. That becomes 6 to the n all over n squared all times 6 to the n. So simplify that. 6 to the n's are going to cancel down to a 1. And you're going to be left with n plus 1 all over n squared. All right. I mean, you know this is a p-test coming in here, but it's a direct comparison. Now, when I'm looking at this, I say, all right, this splits as what? 1 over n plus 1 over n squared. So we're adding something to 1 over n. So I need to do a direct comparison test. And again, I have no idea how you learn this, but let's be formal about this. So the sum is n equals 1 to infinity. Let's do a compound inequality of that. So it's always going to be 0 less than. I mean, these are always positive sums. And that's 1 over n is my harmonic, or my p. That my p-test is going to be devoted to 1 over n based off of this. I'm going to compare this to 1 over n. Now, the reason I'm putting 1 over n in the middle is because if I add something positive, it's going to be positive to 1 over n. It becomes bigger, right? So my n plus 1 all over n squared is going to be on the right side. So from here, I know that this is going to diverge, right? When p equals 1 and we're going from 1 to infinity, that 1 over n is going to diverge. And you should know your p testing walking into this test. So let's use that comparison. So of 1 over n diverges using a p-test. So if the inside diverges, the outside's got to diverge, right? That's a direct comparison test. So the sum of n as n equals 1, or of n equals 1 to infinity, of n plus 1 all over n squared diverges at x equals 6 by the direct comparison test. I always just tell my students to write DCT, but I would spell it out for the AP grader. So they came out hot out of the gate on this one. So it can be shown that f of negative 3, so they plugged in negative 3, equals that. And that the first three terms of this series sums to negative 125 over 144. Show that f of negative 3 minus s of 3 is less than 150. Or 1 over 50, sorry. I don't know why I said that. I don't know. Again, I don't know how you learn this. I always tell my students, like, just plug in the first three terms. Like, find the first three terms. So I'm going to plug in 1, and that gives me what? 2 over 1 all times negative 1/2 to the first. Then I'm going to get what? And then I'm going to plug in a 2, which gives me 3 over n squared is 4. Again, I'm just plugging in 1. Then I'm plugging in 2. And that gives me what? Negative 1/2 times negative 1/2 is a positive 1/4. And then I'm going to add 4/9. So I'm plugging in 3. And then negative 1/2 times negative 1/2 times negative 1/2 is negative 1/8. And to be even more specific, that tells me I have what? A negative 1 plus 3/16, and then minus 4 all over 72. Here's what I got from this. This is an alternating series, right, that is going to decrease in magnitude to 0, right? So I can use the alternating series error bound. So not only did they throw a huge p-test at us in part A where we had to do a direct comparison test, part 2 now is coming after our knowledge of alternating series error bounds, right? So under here I would write that this is an alternating series with terms that decrease to a magnitude of 0. And again, I would hope I have more than 15 minutes from the other parts, those parts being a lot more straightforward, kind of figuring those out a little bit easier. All right. So using the alternate series, or alternating series, sorry, error bound, you know it's either going to be that or a Lagrange, right? And hopefully as you go through all these FRQs with me, you're going to kind of see the differences between years, and you'll kind of have a good feel for how they design these things. So use their notation. They want me to show that f of negative 3 minus s of 3 is going to be less than 150. Now, here's what I would do, and I always just tell my students, you know that the max error in one of these series is going to be in the next term, right? Because it keeps alternating from plus to minus. Again, I have no idea how you learn this, but you should know that the fourth term, or the max error, is in the fourth term. And yes, I do know up front that they gave me this sum of the first three, which was coming from here, and you can kind of see where that came from. I don't really care about that. You didn't really have to go too deeply other than to say, all right, let's calculate what the absolute value of the fourth term is, right? I don't need to do an absolute value because I know my fourth term is going to be positive. but you could put the absolute value around it if it were going to be a negative term. So let's plug in 4, and that gives me 5 over 16. All times what? 1, negative 1/2 to the 4th. 2 to the 4th is 16, so there'd be a positive 1 over 16 in there, which equals 5 over 256. And if you need to calculate 16 times 16, then just do it elementary school style and do it over here or off into the opening somewhere. But if you really divide this out, we know that this is going to be less than 1 over 50, because that would be 1 over 250, or sorry, 5 over 250. And they always make it something so that it's obvious, because you don't have a calculator. And that's all you need to write, is just show the 4th term and then go there. Now, yes, could you don't need to they kind of threw you off with this. I think it's always best to plug some terms to make sure this was an alternating series and you were good to go and you can use the alternating series bound. It's either going to be that or using the Lagrange error bound. All right, find the general term of the Maclaurin series for f prime, and then find the radius of convergence of the Maclaurin series for f prime. Look, you got to be on your game. They're all over the place on this one. Remember, if f has a radius of convergence of 6, then so does its derivative. We can prove it, but you don't have to. You should have learned that, but we'll prove it. So f prime is going to equal the sum as n equals 1 for n equals 1 to infinity. I don't know why I keep saying that. All right, so what are we going to do to take the derivative? We're going to bring down a power of n, right? Multiply that to n plus 1, all times x to the n, minus 1. And then nothing on the bottom is going to be changing when we do. Just apply the power rule to the derivative of this. So bring down the n, and then take this to the n minus 1, and then the bottom is that. So we can clean this up. So that n and n squared become netted out to be an n on the bottom times 6 to the n, and then the top is just going to be n plus 1 all times x to the n minus 1. So that's pretty straightforward. I don't think you needed to prove this one. You could have just stated, because the radius of convergence of f is 6, then f prime also has to have the same radius of convergence. But if you want to get technical, take the limit as n approaches infinity. And again, this is all stemming from your understanding of series and the R of a geometric series, and that has to be less than 1. So you're going to take, and when I do the ratio test, you're always going to be dividing by the general term, but you then want the next term. So I usually just set it up and skip the step where I just flip the general term to the right side here in this product, and I put the n squared up top. I put the 6 to the n up top. I'll bring my n plus 1 to the bottom, and then x to the n. And then I want to do the next term from that. So I'm going to keep adding 1 to all my n's. So this becomes n plus 2 all times x to the n plus 1 all over, what is that, n plus 1 quantity squared all times 6 to the n plus 1. here's how I see it. Like this'll wipe out to 1 because I'm doing n behavior models here. X to the n plus 1 divided by x to the n is just going to be x, the absolute value of x. There's my n squared and my n squared. Again, these are n behavior models. We're going to infinity for n, so that's going to wipe to a 1. And then I'm left with 6 to the n over 6 to the n plus 1, which just becomes 6 to the first on the bottom. So I'm going to apply my limit. And then I'm going to then multiply my 6 over. So there you go. There's my radius of convergence. But I just proved it to you. I'm just showing you how to do it by hand. I think you were probably okay to say because the radius, so because the radius of convergence for f is 6, the radius of convergence for f prime is 6. So that would have cut down some time for you. In this part wouldn't have actually been, this wouldn't have been one of the easier parts to do. Now they're letting g of x equal this sum. Use the ratio test to determine the radius of convergence of the Maclaurin series for g. So I already kind of, this is just me giving you another example of figuring out the ratio, using the ratio test to find the radius of convergence. So let's do that. So let's apply the limit as n approaches infinity. And I told you kind of how I do the ratio test. In the thought process is kind of think about your geometric series where the absolute value of r has to be less than 1, right? Because in order for it to converge. So I'm going to go to my next term, which would give me n plus 2. All times x to the, now be careful, you got to plug n plus 1 in with a parenthesis. That becomes 2n plus 2 when you expand it. The bottom down here becomes n plus 1 quantity squared. And that's all times 3 to the n plus 1. And remember, you're dividing the next term, right, by the general term at n, so that when you do that ratio, it's less than 1, so that the terms just keep decreasing. That's the theory behind it anyway. So I told you I just flip and multiply the general term to the second piece of my product. Now what I do is I kind of figure out what's going on. All right, so my x to the 2n plus 2 divided by x to the 2n. Remember, you subtract, and I'll be left with x squared up top. So I don't need an absolute value around that because it's being squared. So that I've taken care of. Now, n behavior model for n approaching infinity, that would just be n over n is 1. This becomes n squared. I don't care about what that expands to. These will wash off to a 1. And then I'm left with 3 to the n all over 3 to the n plus 1, which becomes just 3 to the first on the bottom when I use my exponent rules, is less than 1. So that gives me x squared is less than 3. Now, when I square root both sides, you got to do a positive and a negative case, right? So the positive case to make this inequality would just give me less than positive root 3, But when I look at the negative case, I got to flip my sign. That's why it becomes greater than. And then I'm going to have negative square root of 3. You could have left it, but I like to show I know my algebra, so it's good here. So now I can answer the question. The radius of convergence use their words of the Maclaurin series, or of the given, I guess, Maclaurin series, is square root of 3. So you can see by going through this, they got pretty technical on you, and it's just all going to depend. And I may roll out in my YouTube channel some of my printables and videos for Taylor and Maclaurin series, some pieces of them to maybe help you prep maybe that last month going into the AP exam. So that was it. You can see 6 was a little bit of a bear, again, but it just depends what you know.